So you may have noticed that there are a lot of theorems. So I prepared this sheet for you to help organize these theorems. One of them, my sheets is blank for some reason. Oh, it's printed both sides. Not really what I wanted, but it will work. All right. So one of them is the mean value theorem. This is what we've been talking about. So what you need to do is sort of keep these different theorems straight. Here are sort of three of the main theorems we've talked about so far on this sheet, which is posted on Google Classroom and also on the handouts page of the website. So first of all, we've been talking about the mean value theorem. All right, f is continuous on AB and closed interval AB and differentiable on the open interval AB. Then at some point C in the open interval AB, f prime of C equals f of B minus f of A over B minus A. So what I want you to do with this sheet that you should immediately print out and have in front of you, or else write your own copy of it on a piece of paper if your printer is unavailable for whatever reason. And I want to go through and break each of these down, because it's important to understand that each of these has hypotheses and it has a conclusion. All right. The hypotheses, that's a plural, by the way. The singular is hypothesis. So if you ever have just one hypothesis, it is a hypothesis. And if you have multiple hypotheses, they are hypotheses. All right. So the hypotheses are the if part of a theorem. So if f is continuous on closed interval and differentiable on the open interval, that's the hypothesis. And the conclusion is the then part. Then at some point C and AB, this magic thing happens. All right. So for the mean value theorem, what I want you to do is really break this apart and look at the hypotheses and the conclusions. Even though you have it written up here, write it again. The hypotheses are f is continuous on the closed interval AB, and f is differentiable on the open interval AB. Now, the AP exam is very fond of all three of these theorems, and they will be looking for ways to test to know if you understand what the hypotheses are and how they relate to the theorem. So you need to know these hypotheses. If we do the AP exam in person, you aren't going to have any notes available. You will have to have this memorized. All right. Of course, if we are still at home for whatever reason, then it'll be open note. But I definitely would not count on that. All right. So these are the hypotheses. The conclusion is, and I'm going to go ahead and use the there exists C, which is somewhere in the open interval AB, such that, we have a symbol for such that, but it won't kill me to write two words, such that f prime of C equals f of B minus f of A over B minus A. All right, so remember a couple of things about hypothesis and conclusion. So first of all, if you want to prove for a function that the theorem does apply, you have to prove that both criteria are true. If you want to prove that the theorem does not apply, you only have to prove that at least one of them is false. Then another thing to bear in mind is, if the hypotheses are true, then the conclusion has to be true. But if the hypotheses are false, that doesn't mean the conclusion is false. If the hypotheses are false, the conclusion could be true or false, and you have no way of knowing which it is. So that's why we say the theorem does not apply. All right. Now, every theorem, in fact, everything in mathematics, but in particular every theorem, has a picture that goes with it. The picture for this theorem is we have a function. Who knows what it looks like? I'll just draw a function f. It looks sort of cubical. And then I have an interval AB, so I have an A and a B, and then I have f of A and f of B. All right. And then I can draw a segment between them, and that segment is called the secant line. Then what the theorem says is that there is at least one point, as long as f is continuous and differentiable, at least one point where the tangent line is parallel to the secant line. In this picture, it looks like there's actually two of them. There don't have to be two of them, but there could be a million of them. There could be infinitely many points between A and B where the tangent is parallel to the secant. But the theorem only says, when it says there exists C, it means there exists at least one C. All right. Now, we can also say these things in words. So the words are, if f is continuous on AB, and differentiable on the open interval AB, then there is a point in the open interval AB where, so the words part is like, what does this really mean? It means that somewhere the instantaneous rate of change is equal to the average rate of change. All right, so that's like really spelling out what the mean value theorem is about. Now, you should try to do that for the intermediate value theorem and the extreme value theorem. And in the next video, I'll run through those and make sure you got the same thing that I got.